So we've saved our project as preliminaryproject.z. And next I'm going to show you a few more advanced registration tools in HistoloZee. So first I'm going to hide the third slice and view only the first and second ones. Additionally, I'm going to turn off edges for the bottom slide so that we only see the first and second ones. I'll also expand the orthogonal cross-section views, and I'm going to bring back the similarity metric window. Oops, the orthogonal window popped out here. Just put it back. Okay. So you might have noticed that some slides are highlighted pink. What does this mean? Well, the pink slides are actually the ones that are fixed for automatic registration. You can change which slide is fixed during automatic registration by clicking on that slide and clicking on the lock at the bottom of the screen, or clicking on the slide and going to the register menu and saying set slide as fixed. This top right view called similarity metric is really interesting. It actually shows you a live view of the image similarity metric between the two slides that we're working on. The fixed slide is the second slide, and the moving slide is the one that is currently highlighted or the one that is active in the slide sorter. And you can see that as I move the slide, the metric image updates on the fly. So this image that you're seeing is actually a visual representation of the mean squared error metric. You can also view the metric itself under the register menu, selecting display metric value. So this value on the bottom right of the similarity metric window is the mean squared error metric between the two slices. When the two slices are well aligned, like here, the metric is low and the similarity metric image is mostly black. In other words, this window gives you a live view of how well aligned the images are. Under the register menu, there's another option called metric masking using threshold. I'm going to turn this off for a second. So now there is no masking applied prior to computing the similarity metric. If I reselect that option and change the threshold of our slice, you'll see that masking is now being applied prior to computing the metric. In most cases, we want to register images with masking applied. In other words, the background will not influence the registration metric if this option is selected. There are other registration similarity metrics, cross-correlation. So the intensity that you see on the screen here corresponds to the cross-correlation value. You can also see that cross-correlation value on the bottom right. So perfectly aligned images will have a lower cross-correlation value. The reason that the cross-correlation value is lower is because I take the negative of the similarity metric. You can select the normalized mutual information metric, in which case the similarity metric window shows you a live view of the histogram of the two images. So when the images are well aligned, your histogram is roughly diagonal, but as they become misaligned, you get these pockets showing, for example, gray matter, white matter overlap, where there shouldn't be any. Again, let me just show you the simplest case. In this case, I've selected the moving image to be equal to the fixed image. Since there is perfect alignment, the joint histogram of the two images, of the same image, is a diagonal line. In the real world case, you never quite get that diagonal line. You can get something close to it, for example, over here. But as you misalign your images, you will have these additional clusters of misregistration. So this one, for example, corresponds to an area that is dark in the fixed image and dark in the moving image. This is bright in the moving image, bright in the fixed image. This is dark in the fixed image, bright in the moving image. In other words, this is a cluster of white matter, gray matter overlap, where there shouldn't be any if the images are perfectly aligned. I'm going to go back to the mean squared error metric and put this window back in the dock. I'll just bring it up for 1 second and fix these windows up. So, with the second slide denoted as fixed and the first one denoted as active, I select histology slide to slide as my current registration, rigid body transform as the transformation, and mean squared error metric. I'm going to go to the transformation parameters of the slide, and all you do is you say run registration, and it stops when ready. Again, this is a feature in development, so registration is not perfect because all of the slide is used in computing the similarity metric, whereas we might just want perfect registration of the hippocampus. You can see that transformation parameters are updated on the fly. Since we selected rigid body transformation, only the IJ translation parameters and the K rotation parameter get updated. We can increase the number of degrees of freedom to isotropic scaling with one more. In this case, both scales in I and J directions move in tandem. You can use isotropic scaling to unlock those two. And you can select full affine. So it's actually not a bad alignment, as you can see with the edges turned on. Not a bad alignment. Again, this feature is currently in development. We're working on improving the optimization steps. And we can make the third slide active now and align that one to the second slide. So there it is. So not only do we see the transformation parameters changing, but we see the slide itself moving in both the orthogonal and slice views. And we can inspect this registration a little bit better by putting edges onto everything. Not bad. We can change the slide that is currently selected as fixed to the third one, for example, and run registration to that slide. And you can, of course, zoom in and see things register on the fly at any level to see if the features that you want are being aligned. And now we'll register the first slide to the third slide. So this just shows one of the drawbacks of automated registration. We don't have full control over which features become aligned, which is why it's very handy to have this interactive registration tool, which lets us fix things up. Okay.